Okay, good afternoon, dear students. In last class, we discussed the salt hydrolysis. The salt hydrolysis example, that is, the salts can be divided into, that is, 4 types of salt. Here, first is the salts of strong acid and strong bases. Salts of strong acids and strong base. Strong base. First one is the salts of strong acids and strong bases. Strong bases. Next, second one, the salts of weak acids and strong bases. The salts of strong acid and strong bases. Here, the weak acids and strong bases. Weak acids and strong bases. Next, third one, salts of strong acids and weak bases. Right, one time is a weak acid, strong base. One time is a strong acid, weak base. Last one is a weak acid, weak base. Next, third one is the salts of here the weak acids, and third one, that is you take strong acid, here weak bases. Strong acids and weak bases. Next, fourth one is a salts of weak acids and weak bases. Salts of weak acids and weak bases. Here, first one is the types of salts here in salt hydrolysis. First one is salts of strong acids and strong bases. Second one is a weak acid, strong base, and third one is a strong acid, weak base, and fourth one is a salts of weak acids and weak bases. Okay, in this, the first one, the strong salts of strong acids and strong bases. In this first one, here examples for the strong acids and strong bases, or the strong acids you use. Example for the salts are sodium chloride. The salts of strong acids and strong bases, that is the sodium chloride, potassium sulfate, and sodium sulfate, and potassium nitrate. These are the examples for this salts of weak acids and strong bases. Here example for this, the salts of weak acids and strong bases. Sodium chloride, example for salts, sodium chloride, potassium chloride, potassium sulfate, sodium sulfate, and potassium nitrate, etc. You take, this is an example, that is a sodium chloride, and here you write sodium chloride NaCl plus aqueous to form Na plus Cl minus. Here this is a sodium salt. I am explaining this one. Okay, here the salts of strong acids and strong bases, sodium chloride plus aqueous solution to form a ions, sodium ion. This is a chloride ion. This is sodium ion and this is chloride ion. And H2O here hydrolysis of sodium chloride. Hydrolysis of sodium chloride. Hydrolysis of sodium chloride organize NaC. Hydrolysis of sodium chloride. Here the hydrolysis of sodium chloride can be represented. This is the sodium chloride plus aqueous solution to form a Na plus sodium ion and chloride ion. Then H2O here to form H2O is a H plus OH minus ions. Here H plus ions and hydrogen ion and hydroxyl ions are formed here. Here this or you can write this overall reaction. This overall reaction. This one you write the overall reaction of this salt, the hydrolysis of salt, that is the sodium chloride. Here you write NaCl plus H2 here. The NaCl plus H2O, the ions are formed here. Na plus Cl minus plus H plus OH minus. The overall reaction here Na plus Cl minus plus H plus OH minus. You get these ions and hydrolysis of salt. You take an example, salt as the sodium chloride. This is a common salt. Sodium chloride and hydrolysis will take place H2O to form a sodium plus chloride ions and hydrogen ion and hydroxyl ion. Here that is there is only dissociation of sodium chloride and here no hydrolysis takes place. This is a dissociation of this sodium chloride salt. Next, this is the example for salts of strong acids and strong bases. Next, second one. Yes, and can here the source. So I written example. This is the first example, that is sodium chloride and KCl and NaCl. First type of salt cycle, there are those examples. And here second one is the salts of weak acids and strong bases. Here the weak acids and strong bases and the sodium acetate and sodium phosphate and sodium carbonate, hydrolysis of sodium acetate. Here these are the example for salts of weak acids. Weak acids means here the CH3 COON. CH3 COON. These salts come under this category. The salts of weak acids and strong bases. The hydrolysis of this one, the weak acids. That the hydrolysis of that one, sodium acetate. This is a sodium acetate. Then right hydrolysis takes place with water molecule. That CH3CONe plus H2. Here the sodium acetate is dissolved in water molecule, then you get the acetic acid and sodium hydroxide. Here this is a H plus and OH minus, and here you get a this one sodium hydroxide, and here you get the acetic acid. This get a acetic acid, here CH3COH plus NaOH. This is a hydrolysis takes place here. This is a sodium acetate, and here the formation of acetate ion and sodium ion. You write this type also. Here, this is a acetate ion, this is a sodium ion, and this hydrolysis with H2O. The formation is acetic acid and Na plus and OH minus, CH3COH plus Na plus OH minus. Na plus you get OH minus here. And the overall reaction, this overall reaction, write the overall reaction. Overall reaction here, the overall reaction is acetate ion and H2O, you get CH3COH and OH minus. This is the CH3CO minus plus H2O to form CH3COH plus OH minus. Okay. This is known as a Ionic hydrolysis. This hydrolysis is known as anionic hydrolysis. Ionic hydrolysis. This is an example of the salts of weak acids and strong bases. Next, third one, the salts of strong acids and weak bases. Next, third one, here the salts of strong acids and weak bases. In strong acids and weak bases, here in this category, the salts are the ammonium chloride and calcium chloride. Ammonium chloride, calcium chloride, and ammonium nitrate. These are, for example, here ammonium chloride, calcium chloride, and ammonium nitrate. Ammonium chloride NH4Cl, and another example calcium chloride, etc. Ammonium chloride, calcium chloride, etc. Okay, here I write the hydrolysis here. The hydrolysis of ammonium chloride. Here hydrolysis of ammonium chloride NH4Cl plus hydrolysis H2O. The formation is this ammonium hydroxide, here H plus and OH minus. Okay, here you get a ammonium hydroxide, and here you get HCl. This one, ammonium hydroxide plus HCl. NH4OH plus HCl. This is a salt hydrolysis of ammonium chloride in the category of salts of strong acids and weak bases. Or you can write on this one, you write the ammonium chloride is NH4 plus Cl minus plus H2. NH4 plus Cl minus plus H2O to form, that is this one, NH4OH. Here this one, to form this one, NH4OH plus H plus Cl minus. And the overall reaction is this one. You get this is a NH4 plus and H2O to form NH4OH. NH4 plus H2O, that is H plus OH minus to form NH4OH, ammonium hydroxide plus H plus. And here in second category, it comes that is known as a Ionic Hydrolysis. Here, this is known as a Cationic Hydrolysis. This process is known as a Cationic Hydrolysis. Cationic Hydrolysis. This example comes under this one, the salts of strong acids and weak bases. Okay, next one, fourth one, the salts of weak acids and weak bases. Weak acids and weak bases, here they comes under, that is a ammonium acetate and another ammonium cyanide, and only here this comes under this category. Then it hydrolysis takes place. Next, salts of weak acids and weak bases. In this category comes the example for this weak acids and weak bases are ammonium, that is ammonium acetate. Example CH3 COO NH4. CH3 COO NH4. Here it is a hydrolysis takes place, that is CH3 COO NH4, and formation is acetic acid and ammonium hydroxide. Here CH3 COO NH4 plus H2O, here H plus OH minus, and here this get acetic acid and this get hydroxide, alkali. Here the formation of weak acid. Weak acid means this CH3 COOH, acetic acid. CH3 COOH plus here water. The formation is ammonium hydroxide, weak bases, plus acetic acid is a weak acid and ammonium hydroxide is a weak base. Here NH4OH. This is a acetic acid and ammonium hydroxide. And here the oral reaction is comes here CH3 CO minus This is CH3 CO minus plus this one NH4 plus here the water molecule H2O, overall reaction H2O, H plus OH minus, and this jet here urine or this direction, and the formation of acetic acid CH3 COOH plus ammonium hydroxide. So this is a oral reaction, and here this reaction involves the anionic as well as cationic hydrolysis. Here this reaction involves this one anionic, and this one cationic and cationic hydrolysis. Okay, see here, this is a salts of weak acids and weak bases. In the first one, that is a salts of strong acids and strong bases. Strong acids, strong bases means strong acid is HCl, and strong base is the sodium hydroxide. Sodium hydroxide versus HCl, hydrogen chloride. And second is the salts of weak acids and strong bases. Weak acid means this one, weak acid, strong base. This is a strong, this one is a strong, this is a acid, strong base. Second is a strong acid, that is a second is a weak acid, strong base. Weak acid means this one, CH3, this is first one, this is the second one, CH3 COOH versus NaOH. This is a weak acid, this is a strong base. Next, third one is a here the strong acid, weak base. Strong acid is a HCl, weak base is a NH4OH. Strong acid, weak base. This is a strong acid and weak base is third example. And fourth one is here, last one, fourth one, this one, weak acid, weak base, CH3 COOH and NH4OH. This is a weak acid versus weak base. These are the examples for the in conductometric titrations. This reaction is known as the anionic and cationic hydrolysis. Okay, see here, this is the first one. This is a conductometric titration versus strong acid versus strong base. And here, conductometric titration, weak acid versus strong base. Conductometric titration, strong acid, weak base. Conductometric titration, weak acid, weak base. Next, that is hydrolysis constant. Over here, the hydrolysis constant. The salt hydrolysis, or it is also known as the hydrolysis of salt. Okay, next concept, hydrolysis constant. Hydrolysis constant. Okay, here the hydrolysis constant of salt, that is you take sodium acetate. Example is a sodium acetate, and here Ba is the example for this salt hydrolysis. There is a hydrolysis constant. This is represented as Ba, and here the hydrolysis of Ba, this will hydrolyze this Ba, and here Ba plus it is a aqueous solution plus H2O, Ba plus H2O cation, and here the formation of acid, hard acid HCl. One H is present, the acid is present here, plus remaining here H plus OH minus. Here HA and POH. Here the formation is acid and base, salt, and here the formation of acid and base. Here the applying of chemical equilibrium. On this you apply the law of chemical equilibrium, and this reaction is get at chemical equilibrium. K is a constant at a chemical equilibrium. You write K is equals to, right? This one HA, concentration of HA, acid, BOH base, and here salt Ba and H2O is equals to K is a constant. That is a equilibrium constant. This K is a equilibrium constant. Equilibrium constant. Here the K is a equilibrium constant, since here the water is represented as very large or excess. Here the water is represented, that is a very large or excess in the aqueous solution, and its concentration of H2O is mainly, that is regarded as a constant, and here the HA and BOH, and this is a B, all divided by B, and here the K is very large and excess, and this H2O is taken as a constant. Here, right, the constant is taken water, HA, the equation may be written as BOH divided by BA. Therefore, this is equals to this H2O constant here, H2O, concentration of H2O into K, or K into concentration of H2O, and this is written as KH. This is represented as KH. KH is the hydrolysis constant. This KH is a hydrolysis constant here. This KH is called hydrolysis constant. Hydrolysis constant here. Here this HA and BOH, this HA, concentration of HA and concentration of BOH represented molar concentration of free acid and the free base produced B. That is here this product represents the molar concentration of the unhydrolyzed salt. This is a concentration of molar concentration of free acid, and this is a molar concentration of free base, and this is a unhydrolyzed salt. The molar concentration of unhydrolyzed salt. And here the general expression for this hydrolysis constant, it may be written as here the hydrolysis here KH, because this is a free acid, this is a free base, and this is a unhydrolyzed salt. Here in general representation of hydrolysis constant, this is a free acid, K is equals to free acid, and here free base divided by this one, that is a unhydrolyzed salt. Sorry, this one written as KH. KH is divided by this BA is the unhydrolyzed salt. Unhydrolyzed salt. Okay, this is a general representation of hydrolysis constant, and KH is equals to free acid, free free bases, free acid, free base, and divided by unhydrolyzed salt. Okay, this is known as the hydrolysis constant. Here you take example for hydrolysis constant, that is the hydrolysis of water. That is hydrolysis of sodium acetate. Sodium acetate. Sodium acetate. Okay. CH3 CON. This is hydrolyzed H2O. And here the formation, this is the H plus OH minus. This get here and this get CH3 COH and A plus and OH minus. CH3 COH plus and A plus Cl minus. Sorry, H minus. OH minus. Then these here the sodium ions, here the formation of this is the sodium acetate hydrolyzed H2 molecule to form acetic acid plus sodium ion plus hydroxyl ions, and here the sodium ion is a common ion. This sodium ion is a common ion, and it may be left out, and the equation may be represented here. This is a common ion, this is left out, and the equation is written as CH3COO minus. Okay, here this CH3COO minus, and then it is hydrolyzed. This one CH3COO minus plus H2O, and here we get the OH minus ion and free acid and free base. These are the OH minus, this is a free base, plus CH3COOH. This is a free acid. Okay, this is an example for hydrolysis constant, and here you write the hydrolysis constant is KH is equals to free acid or free base OH and CH3 COH divided by unhydrolyzed salt, that is CH3CO minus or Na. CH3CO. This get the hydrolysis constant. Here the KH is represented as hydrolysis constant, or it is known as the hydrolysis constant. This one is a hydrolysis constant. Hydrolysis constant. This is the hydrolysis is completed. Next, the ionization. You know already ionization, or it is also known as the dissociation. Here, the ionization constant or a dissociation constant. I already discussed the dissociation constant and ionization constant here, and only the formula of dissociation constant, that is the dissociation constant is a K is equals to concentration alpha square divided by 1 minus alpha. And next the ionic product of salt, that is the ionic product of water. In your syllabus, the ionic product of water. And here the ionic product of water, or H2O. The ionic product of water. This is also important. That is the 4 marks question. Ionic product of water. Here, the ionic product of water. Water in the presence of acid here. Ionic product means water, H2O. Here, water is a H2O, H plus OH minus. And here, in water molecule, the presence of acid accepts the protons and hence act as a base. Here the acid accepts a proton and acts as a base. The presence of base by donating proton. Here it accepts acid is behaves as a base, and base donate proton behaves as a acid. In this case, the pure water. Here in this, the pure water, some of its the molecule are the acid and some as the base, accepting and donating the proton of each with each other. And here in fact the reaction of the donating of protons and accepting of protons in water molecule is called that as a ionic product of water. Here the ionic product of water, liquid is this water H2O plus H2O. The formation is hydronium, and here this is the liquid and this is also liquid, and here this is the acid and this is the acid and this is the base. Here the acid is accept proton is called, it form a electrode is a, that is base. Here this is a accepting accepting this proton, the formation is base. This base is donate proton and this is known as a behaves as a base. That is a conjugated base and conjugated acid base. The formation of acid base. This form H3O plus here one H is comes to here, that is here this is a accept the acid and behaves as a base, conjugated base, and here only remaining OH minus. This is a donating one H here from to this acid, and this is a behaves as a base. And next here this is a water molecule, remaining is OH minus, and this is a behaves as a acid. And this is a conjugate acid, conjugate base. Conjugate acid base here. Acid base here, base acid. The conjugate, this is known as a conjugate acid base pair. And here the ionic product of water, applying the law of mass action, and this formula here, write the applying law of mass action for this equation and this reaction, and then the formation of, this is a constant, this K is the ionic product of water, K is equals to H3O plus OH minus, divided by, we get here the H2, divided by H2. This one is, this is a free of here, you write KS2O, then this is equals to H3O plus and OH minus, H3O and O plus and OH minus, here change in concentration, this one here in this, the change in concentration of water is neglected here. Change in concentration of water is neglected in large excess, and this one KH2O is equals to H3O plus and OH minus is written as, that is a K ionic product of water, that is the KW, water is known as a W, and KW is equals to H plus and OH minus. The water is here, KW is equals to H plus, and here you write OH minus A plus, that is KW, the ionic product of water, K is equals to H, concentration of H plus and the concentration of OH minus. And in one can write in a liter of pure water, in 1 liter of pure water only it is a 10 to the power of minus 7 moles, and here the water gets ionized, and it is ionized, the water is ionized. This is a per 1 liter it is a 10 to the power of minus moles of pure water, and then water is gets ionized, then giving 10 to the power of minus 7 moles of hydrogen ion, and the 10 to the power of minus 7 moles of the OH minus, that is the hydroxyl ions at 298 Kelvin temperature. And here you write the KW is equals to H plus and OH minus, and this is written as 1.10 to the power of minus 7. This is a 1.10. Now we write 1.0. 1.0 into 10 to the power of minus 7 into 1.0 10 to the power of minus 7 into 1.0 into 10 to the power of minus 7. Here you get, that is a 1.0 into 10 to the power of minus 14 to 10 to the power of minus 14. This is a ionic product of water, and it changes the concentration of the water. Then if this excess, the water is neglected, only here the ionic product of water is H plus and OH minus. This, and it ionized It's either 1.0 into 10 to minus 7 and 1.0 into 10 to minus 7. You get the value is 1.0 into 10 to the power of minus 7. Then the concentration of hydrogen ion in predicts the acidity and basicity or neutral conditions of solution. Neutral conditions of air. It predicts the hydrogen ion is predicts the acidity and basicity and also the neutral. Here, the concentration of H plus, that is a hydrogen ion, is greater than OH minus ion, then the solution is acidic. Here, solution is acidic. And solution is acidic. After the solution is basic. Here, H plus, the concentration of hydrogen ion is less than the concentration of OH minus ion. The solution is basic. The solution is basic. And then the H plus ion is equals to the OH minus ion. The solution is neutral. Here H plus ion, concentration of H plus ion is equal to the concentration of hydrogen ion. The solution is basic. Solution is neutral. Solution is neutral. When it depends, the hydrogen ion is greater than hydroxyl ion, the solution is acidic, and the hydrogen ion is less than hydroxyl ion, then the solution is basic, and the hydrogen ion is equal to the hydroxyl ion, the solution is neutral. And here, considering the Kw is equals to, that is H plus, concentration of H plus and concentration of OH minus. Then taking the negative logarithm of this, you are taking the negative logarithm of this H plus and OH minus. Here negative log of Kw is equals to negative log of H plus and OH minus. Here negative log of Kw, here we taking negative logarithm on both sides. Here log of Kw is equals to minus log of H plus and OH minus. Here we taken the negative log, that is log of Kw is equals to minus log of H plus and OH minus, and afterwards is a negative log. Therefore this is equals to minus log of H plus and here the minus log of OH minus. Right, we simplify minus log of H plus minus log of OH minus, and afterwards here the H plus means that is a 1.0 into 10 to the power of minus 7 into 1.0 into 10 to the power of minus 7. You get here minus, that is log of H plus means here that is 1.0 into 10 to the power of minus 7. Minus, it is multiplied by, only this you are simplified minus log of H plus, and here this is applied to this OH minus log of OH minus, this is multiplied by 1.0 into 10 to the power of minus 7. Okay, finally you get the minus log of 10 to the power of minus 7. Here minus log of 10 to the power of minus 7. 10 to the power minus 7. Here the pK, that is ionic product of water, pKW, that is ionic product of water is equals to pH, this one, pH plus pOH. This is a hydrogen and this is a hydroxyl ion. And here this one, the logarithm of H plus is a pH and logarithm of OH minus is a, that is pOH, and here you write, therefore this is equals to the 40, that is you get a 40, and product of water pKW is equals to pH plus pOH, therefore this is finally it is a 40 is a value. This is a ionic product of water. Okay, I'll stop here only and continue in next class.